Okay, this is a heater, oil-filled heater, and it quit working. And so I tore it apart trying to find out what's going on, and I just want to show how you can test this thing out. So it's only 110 volts. What it's going to do is we're going to have voltage coming in. So the voltage is going to come in to these two terminals right here, here and here. And so I'm going to testing. That's showing me that I've got 23 ohms on there, and over here I've got 38 ohms. So it tells me I've got the larger element on this side and the smaller element on this side. That's the low and the high. They're not shorted out. You can see they don't go. They're not going to ground. So that's good. So once I tested that, I knew that the heater element wasn't bad. I had to figure out what else could be wrong. And the one thing that these are known for doing is taking out the little tiny fuse that goes through this line right here. That's the voltage coming in. This white wire comes through right here. Let me get it. Comes through right here, and it's split between the black wire here, and then comes in over here and goes to a blue wire. Blue wire being the common. It goes up here through this is a thermal switch. Variable thermal. It's got a bimetal thing into it, so you can set your temperature and it'll kick in and out. And then this switch here is a high-low, and it's high-low and off. So I'm going to test. What I want to do is I want to test the circuit between the coming in. Let's see what we got here. So I'm going to test the circuit between the plug going into the wall and the wire coming in. So it's not on the ground side. There's no power there, or no continuity there. Let me check over here to make sure, and that's the wide one. The wide one should be the common, and there it is. It's got continuity all the way from there up through here and down through here. So all of this common side is working. So let's go back to the side that would be hot, and that's where I came in testing this wire right here. This is the power coming in, and you can see there's nothing there, no continuity. But if I come down here, there's continuity. This little tiny thing right here is a thermal switch. If the unit overheats, it blows this basically a fuse, thermal fuse, I'm sorry. So what I'm going to do is I'm going to replace it. There are so many of these get thrown away because of this little tiny piece right here. Can you see that?
Mm-hmm. Mm-hmm.
That's all it is. Mm. And the biggest thing on this to watch for is that the temperature that it kicks out at. It is 128 degrees Celsius. You can do the conversion on it. It's a 250 volt 10 amp or 125 volt 15 amp. That same fuse. So I need to replace it. That's what I'm going to do right here. I'm going to replace it just like that. Two ways you can do this. You can either try to get this thing apart, put it in there, or you can do what I want to do, and that's I'm going to solder it in. This material right here is flexible, and it's like heat shrink. I believe it is a flexible heat shrink. So I pulled it way up away from it, and I'm going to cut that piece out, and I'm going to solder that in there. And see if I can do it without too much problem. Get that out of there, and I'll show you here too. So you can see here, and looking at this over here, it's going through me. There it is. That was actually giving it continuity. You gotta be careful about that. So there's nothing there. So that's what we're putting this in for. And I got let me turn my heat on. So this is rosin core solder, and this is a Weller. This is a very nice soldering gun. You don't have to have this nice of one, but it does help to have a nice one. Get enough heat into it. I might be drawing the heat out with this. See if it's holding. That's one.
If those are always going out, why don't they just make them so they're plug and play? You know what
Well,
I mean?
they actually do make other thermal switches that can be reset. This one doesn't have one. I think I got it.
Mhm.
Get a little bit of solder on the tip, and let the heat build up down here, and eventually you'll see that it'll flow into the part. The idea is to get enough heat. There it goes. I don't know if you've seen that or not, but it went all of a sudden became fluid, very fluid, and got in between the two parts. Now you always want to leave a little bit of solder on the tip to keep it clean and keep it tinned. That one needs to be cleaned and then resoldered. Made by your pair pliers. I need some small snips is what I need, but I don't have any here. Got a gob of solder hanging off the side here, and I want to get that off there. That's better, because I got to be able to slide this on. So now that it's cooled down, I can try to put this back over top of it.
Right.
It's an insulation. Slide over it. That's what protects it from shorting out. Let me get a pair of pliers so I can try to slide it on.
Well, just like that.
I'm going to cover it off. Now, I could have cut this off there and put some heat shrink on it. I do have some heat shrink. But if you do that, make sure you slide the heat shrink far enough down. Yeah, we're getting caught right here. Oh, make sure you slide it far enough down that you don't send heat down to it and it starts shrinking down where you don't want it.
Got it.
And there it is. Now let's test it.
All right.
Let me shut that off before somebody gets hurt. What I'm going to do, I want to have power from my cord, which is the small one, the hot one. And it should be here. I should have continuity now.
Let's see. Don't move real fast so I can.
Oh. What happened there? I hope I didn't have a defective part. I guess I should have checked that too, huh? Well, that's not good.
Oh, there it went.
Yeah, let me try that. Well,
That was weird. That went. Didn't you see it?
yeah, but I can do that. That's me,
Oh, okay.
I think. Yeah, that's me.
Oh.
Okay, so we're going to back up. See what happened. Probably need to buy them things by the boatload.
Is there a right direction or wrong direction to solder that on?
It's not a diode. Well, that is a defective part.
Did they send you more than one?
Nope. I only ordered one.
All right, guess we're gonna do that again, huh?
Yeah, I guess we're going to do that again. When we left off, we found out that we had no continuity through our new thermal switch. Well, that's it right there. So I'm trying to figure out, well, what happened? Well, it's a thermal switch. And when I soldered it, I put heat into it higher than what it was rated at, so it broke the switch. And right now I've got one going to go in. We're going to try this. This has got continuity through it right now. So what I'm going to do is I'm going to solder again. I'm going to try soldering. If I can't get it to solder, then I'm going to take and use the clips, which I really don't like because it's not a good connection. So what I'm doing, I'm wrapping this in a wet cloth and using that as my coolant because I really don't need a lot of solder. I just want to make a connection, and I have reduced my soldering temperature down, which may cause me problems, but we're going to find out. Yeah, and I find it probably is because it's already causing a no melt situation. So let's move it up a little bit. You take it up to 450. I gotta be able to get solder to melt, so we gotta have a high enough temperature to make solder melt, but a cool enough temperature to not take the thermal switch out. Hold on, I gotta do my this is moving around way too much. I gotta get this wrapped in there really good and tight. So I'm having two things going on here. I'm trying to cool and heat at the same time, and it can be done. And I may have to kick my heat up enough so I get instant heat at the connection and not up the thing. I got this. I need this. I think I got it. Okay. We'll see if it's still connected. And no, not a good enough solder. So I didn't get enough heat into the tip, and between the wire, this wire and that wire. So we'll do it again. Matter of fact, maybe what I'll do is I'll heat on this side. Try heat from this side. I won't be able to do that.
Why can't you shrink wrap it?
You can, but you got to make the connection.
Oh.
The wire's got to have a good connection because you're going to run electricity through it. If it's a loose connection, it's going to cause heat, which will cause the same problem we got right here. I'm not getting enough heat down in here. Let's take this up. We'll go up. We'll go from this side. We'll see. Did it hold? Yep. Now let's see. Did we hurt our? So this is the little brass connector that they used, that they crimped it, and that would work. But I would rather have a soldered connection. It's better, it's stronger, and it's not going to have a. It's just going to work. It's just the way electricity should be. It should be a good connection. So do we still have continuity here, or did I hurt it? Still working. Okay, that's a plus. We're going to try to do the other side, same way. So this is just a wet rag. And in my years of doing electrical plumbing with my dad, that was one of, if you were working on a valve and you didn't want to ruin the valve, solenoid valve, that's what you did. You protected it with a wet rag. So I'm using the same idea here. Keeping a wet rag, because a wet rag is going to keep it's going to keep it cool. It's going to try to keep it cool. So I'm going to do the same thing here. So I've got it up at over 700 degrees right now because I'm trying to generate enough heat right here at the site. They have it. And solder, you can cool solder down with a right away.
Yeah, I was surprised that you can pull on it and it doesn't pull apart.
Yeah, well, it's because it's going back together.
Yeah,
so
you know, if you use super
let's check
glue,
it.
It's got to sit there for hours.
Yeah, well, you're using metal. It's just about like brazing or welding. Now, you would not want to cool down a braze real fast or a weld real fast. You'll crack it, or you'll change the characteristic of it. But this has got a lot of, well, it's a good. That's what we want.
Okay.
And it should be good all the way down to here. So I should have continuity from this end of this wire, which this wire goes up here, comes in here, and then the black wire comes all the way to here. And it's telling me that I've got a connection.
Okay.
And that'll make that work.
Okay.
So the next thing to do is slide all this back on there. And this does have a insulation on the inside of it, so heat shrink would work, but you're going to have insulation on top of it too.
And then you have to, I mean, how do you see inside that to make sure that your connection's made, right?
Well,
Yeah.
yeah.
Yeah, you just don't get the connection sometimes.
The connection's not going to come apart. So we're insulating it with that too. So I guess you could put some insulation on the inside and heat shrink over top of it.
Yeah. There it goes. Almost.
Yeah, it's grabbing right here.
Hope you're not pulling it apart in there.
No, it's not. Stuck right here. And if it stays stuck, we'll put heat shrink on it. Because you can't have bare wire inside here. A little bit farther. And I probably could tape that end. Yeah, the insulation is sticking. I got it. I got enough down there. All right, so these wires, these are a little clip-in wire right here. It just kind of goes into this connector right here. And it kind of, you push in and it grabs. So I don't know if you see it right there. So it grabbed it. So in order to undo these, you can't just pull these out. There's a little brass piece in there that's pushing up against the end of it. So you push in here, just like that, and you can get them out. You can do all of these the same way. That's how that comes apart. Okay, so all of that's back together. I gotta tie this up here. And a whole bunch of these are nice heaters. Some people like them, some don't like them, but most people that have them like them. But they end up throwing them away because of that little thermal fuse. Because it quits working, and we're a throwaway society. We throw everything away. I think this idea of this clip is to keep it so you can't jerk the wire out of the switch. It goes like that.
That. Okay, those are hooked up. Now what?
So let me get my picture so I get it hooked up without trying twice. So we have 3 connections. One of them is going to be common. It looks like this is the common. This is, but I got to make sure I put the black and the white wire on the right 2 wires. And I just took a picture of it before I took it apart. Here's what we got. So that down there is the white wire. So the blue wire is on the bottom where the 2 things is, and then the white wire would be over here, and the other wire, the white wire here, and the the black wire? Yeah, brown wire. So it goes like that. Brown wire over here, white wire over here, blue wire on the bottom. Let me bend this straight. Wow, got some tension on that thing.
Oh, those just slip in?
Yep, they slide in like that.
That's the blue.
Yep, brown wire here. And
Can't see it. It's got bad lighting.
yep, pulling against me.
Why is that plastic part pulled out there? Do you have to push it back in?
Hmm?
This is up. Up there you go.
I got another 2 little screws. That's
Here, right here's a couple.
that's the 2 I want. Okay. And that should work. Try. We're either going to get smoke,
Or fire.
fire, or pop circuit, or it's going to work.
Ah, I see a light came on.
Yeah, we got lights.
Mm-hmm.
And this heater would not heat. We'll start out on low.
Does it turn off? You had it on max.
Oh, there's off.
Okay.
So low is one element, medium is the other element with the higher resistance, and high is both elements on at the same time.
Okay. Those elements being the two things you just hooked together. Those,
Down there I hooked. There's
the brown
there's
and
a
the.
common, and then there's each one of
Oh,
those.
was that the one you soldered?
No,
Oh, that's the other one. Okay.
that's the thermal switch that
The one
cut
you
out if
just
it gets
slipped
too hot.
together.
Well, let's turn it up. Oh, I'm feeling heat. Yeah, it's heating down here at the bottom. It's heating down here.
Okay. Well, then that's that.
Yeah, if I had my temperature thing, I could show you that.
I trust you. Okay, is that a wrap?
Yep. I'll let it run, and we're not gonna watch it for 15 minutes to watch it heat up. But yeah, it's working.
Okay.
It's heating. Before it wouldn't even heat.
Okay. Thank you.
All right. Over here, 15.
I'm seeing it's going. It's going. Okay.
Okay, 15 minutes later.
The right position. So for now, keeping it to the
This is on the bottom. This is where the heating elements are at, down here in the bottom. And then the oil travels up, comes to the top,
As long as it's close,
circulates,
you know, we should be fine for testing. So
Okay.
let's
hot.
see how
And it is on high. So both elements are running right now.
Okay. Great. We fixed it.
Yep.
Okay.
Okay. Completed. Thank you for looking at our videos and watching it. If you like what you see, give us a thumbs up. And if you like it a lot, look at my other videos and subscribe. I'd appreciate it.